This screencast is to show the oxymercuration mechanism of an unsubstituted alkene. The first step in this reaction mechanism happens when the pi bond attacks the mercury and one of the acetate groups leaves. This gives us a mercurinium ion. The mercurinium ion is analogous to a bromonium ion in the sense that it's a three-membered ring. It's also analogous to the bromonium ion in the sense that it's going to be partial charges on the mercury and the carbon when the alkene is unsymmetrically substituted. So thus, in the next step, when the water attacks, the water is more likely to attack at the carbon that has a larger positive charge. It's not really easy to show the stereochemistry of this attack, but it is an anti-addition, so the water is attacking from the backside of where the mercury is. Thus, when I get this reaction to happen, the water is going to be on the back side if the mercury is on the front side. And when the water comes in, it pushes the ethyl group to the front so that the ethyl is cis to the mercury. The next step is deprotonation of this protonated intermediate to give us a neutral intermediate. So now I have a net anti-addition of mercury and OH to my unsymmetrical alkene. These steps are followed up by a second reaction with sodium borohydride. You're not responsible for understanding the mechanism of this reaction, but what happens in this reaction is the mercury is replaced with the hydrogen to give us this alcohol, which is the Markovnikov alcohol product. So this regiochemistry follows Markovnikov's rule.